Hello everyone. So previously we had discussed on the topic this one, designing a unique ID generator service, right? So we successfully designed it as well. Now let's do one thing. Let's move on with a designing a parking lot, right? So let's see what the question states here. Design and implement an object-oriented parking lot system that supports multiple levels and slot sizes. Yep, that should support multiple levels as well as the slot sizes. The system should allow vehicles to park, unpark, and display the parking status all within a single file, right? All within a single file. Let's do this one, not with the Java actually. This one, what do we call? Python actually. This is fine. Yep. First, let's do one thing. Let's go with the this one functional as well as the non-functional requirement. Let's collect the functional as well as the non-functional requirement. And then let's go with the concurrency as well as the data model. Then after doing that, we can just discuss the UML diagram and then let's write the code. And then finally, let's discuss the limitations of the code. Along with the limitations of the code, let's move on with the this one, the last topic. This one, what do we call? Alternative algorithms and the trade-offs, nothing but the summary part. Yep. So first, as usual, let's discuss the functional end or let's collect the functional and non-functional requirements. Yeah. First, let's discuss the functional requirements or let's get the functional. Let's discuss the functional requirement actually. Yeah. Yeah. First step here would be so we have to create a parking lot with configurable levels as well as the slots per level. Yeah, this is fine. Now we should be able to park a level and return a ticket. Yeah, so this is also one of the functional requirement. Yep. So we should be able to unpark using the ticket, meaning unparking in the sense it frees the slot and we should be able to return the fee, right? So after unpacking, obviously, slot should be freed, right? And also we should be able to return the fee, right? So this is fine. Next, let's go with the fourth one, nothing but query current status occupied slots. We should be able to query the current status occupied slots, free slots per level based on the each level. We should be able to free the slots per level, locate the vehicle by plate or ticket. We should be able to locate the vehicle by plate or ticket. This is fine. Let's move on with the final one. We should be able to support the simple CLI demo operations, whether it may be park, leave, status in a single file. As we are just solving the problem, so we'll be going with a single file, right? Yep. So this is fine, man. So this is about the functional requirements, yeah. So now let's move on with the non-functional requirements. Yep. So non-functional requirements in the sense, first we'll be going with a this one single file. Yep, this is fine. So the next thing is it has to be thread safe or it should be thread safe for the concurrent park or unpark operations. It should be thread safe for the concurrent park or unpark operations, right? So the third one, minimal dependencies. Yep, so this is fine. The fourth one, clear, concise, and maintainable with small memory footprint. With small memory footprint in the sense we'll be going with a in memory. We should be going with the in memory only. Yeah, this is fine. So and here we should be able to go with a fast allocation, meaning big of L into S worst case, right? Right, worst case in the sense where L is nothing but equivalent to the levels and S is nothing but it should be equivalent to the slots per level, right? This is acceptable as we are just going with the demo code, right? So this is fine, man. Now let's move on with the algorithm choice. Yeah, let's move on with the algorithm choice. So first, let me tell you, we will be going with a this one first fit across the levels algorithm. First fit across levels means we have to scan or we will be scanning the levels in order, picking the first compatible free slot. Yeah, that's what we are doing. Why we will be going with this? Basically due to the simplicity and deterministic behavior, right? So this is good for the demo or solving the LLD problem. Yep, so this is good for the demo. Yep, so we'll be going with a low bookkeeping overhead. This also we have to keep in mind. And it is also good for typical parking lot sizes. This is fast and predictable as well, right? So we can just discuss the alternatives as well. We can go with a best fit in the sense minimum wasted space, right? So but when we are going with a or when we will be going with a best fit, so it will be computation will be more computation or more calculation actually, but slightly better space usage. Yep, so this is fine. Or we can go with a heuristic as well, meaning large this one reserve we are able to reserve large slots for the large vehicles when we go with a heuristic, right? So it reduces the fragmentation, but needs tuning, right? So, or one more thing, you can just think of it. We can just go with a priority queue per slot size that will be because of logarithmic n allocation, right? So this is faster, very faster at scale, but it is complex, right? So when we go with a priority queue, it is complex. So this is fine, I believe. Now we are done with the algorithmic, this one algorithm choice. Let's move on with the concurrency as well as the data model. First, let's go with the data model. So I have written parking lot in the sense it holds the levels. So this holds levels, right? Parking lot holds levels. So this is fine. Also, um, uh, we will be going with the global maps, nothing but the ticket map, ticket ID per slot, and plate map and plate per ticket ID, right? So this one we have to keep in mind. So this is for the parking lot. Yeah. So next we'll be going with the level. Level actually, basically it holds slots, right? Level quite obviously holds the slots. Slots in the sense list of parking slot, right? It holds the slot actually. Yep. So this is fine, I believe. So next we will be going with a parking slot. Parking slot in the sense we have to consider the attributes ID, size, occupied by. So we will be going with ID, we'll be going with size, and we will be going with a occupied by. Size as well as occupied by. Let me consider this one. Yeah, these three things. ID, size as well as the occupied by, right? So next let's consider the vehicle. Vehicle in the sense we will be going with the attributes actually. Plate as well as the V type, vehicle type, right? So plate which is of the type string and vehicle type which is of the type enum. So let me write here plate actually which is of the type string, and uh, we can go with a vehicle type as well. Vehicle type which is of the type enum, right? So this is fine. The final one is ticket. Ticket we have for each vehicle we'll be going with a, or we should be able to go with a unique ID, right? For each vehicle we have to go with a unique ID. So this is very important. And also we will be going with a plate, right? So we'll be going with a plate. And one more thing, we can consider slot ID as well as the park time, these two things, right? So let's go with the slot ID as well as the park time. Park time, I'll just write PT here. So this is fine. Yep. So this is it for the data model. Simple one. We are going with a pretty simple one, right? So this is fine. Now let's move on with the concurrency model. Concurrency model, let's do one thing. The first step here would be using a single threading dot log. So this one, using a single threading dot log means we should we will be going with a threading log, this one single threading dot log, nothing but the re-enter at parking lot instance, just to protect the allocation or release and maps, right? So this is fine. Yep. The next one is log granularity. When I say log granularity, you would have already guessed that I'm speaking of the cores actually. Cores in the sense one log to keep this one code simple and correct, right? So we'll just go with a one log here. So just to keep the code simple and correct. Yep. So this is fine. Next, let's move on with the for large scale systems. For large scale systems in the sense, uh, let's make use of per level or per slot logs and optimistic allocation with CAS or DP transactions. This one, not DP, DB actually, database transactions, right? So the final one here, this one. Let me tell you one more thing here. So all read-only queries may be served without lock or with lock for the consistent snapshots. Yeah. Uh, Basically demo uses log for consistency. Yep. So this is fine, man. Now this is about the concurrency model. Let's move on with the this part. What do we call UML diagram part? Yeah. So UML diagram here. First one we'll be going with the main parking lot. This one. What do we call class actually? This consists of the levels we have already discussed, right? Levels, ticket map as well, plate map as well, and then the lock, then the lock, right? So first one here we have levels. So level consists of the level ID as well as the slots for the vehicles, right? Level ID based on the ID, right? In the particular level. So then slots as well. We should go with the slots as well, right? Available slots, or a slot is already this one not available, right? Available, and this one unavailable slots we have to go with, right? So this is fine. Next, let's go with the ticket. ticket which consists of mainly these things. One is ticket ID, parameters plate, this one slot ID, as well as the park date, right? So this is related to the parking lot directly, right? So ticket is related to the parking lot directly, and level is this one related to the parking lot directly. Level is also related to the parking lot directly, and parking slot is directly related to the level. Parking slot is directly related to the level, right? And parking slot consists of the slot ID, size, as well as the occupied by, as well as the occupied by, right? So this is fine. Yep. Now we are done with a UML diagram, right? So we are done with a UML diagram. And one more thing here. So vehicle consists of the data structure. So this one, we can just go with here, plate, comma, this one. What do we call vehicle type? Yep. So this is fine. So this is the UML diagram. Just have a look into it. The same thing, whatever we have used in the UML diagram, that will be making use of it in the code, right? So we'll be implementing certain things in the form of code, but we'll be making use of same methods, parameters that we have mentioned here, right? So just have a look into it. Yep. So this is fine. Now we are done with the UML diagram part. Let's start writing the code. Yep. We are good to write the code. Let's start writing the code. So yeah, let's start writing the code. Initially, let's import certain things that we need, man. Yeah. So I'll just go with first import here. What shall I import? Threading. Yep. So this provides log for the thread safety. Next, let's go with a this one import time. Uh, Let me give here import time. So this is nothing but it is used to record the timestamps and compute or calculate the durations. Yep. Next, let's go with a this one UUID. Right. So UUID you should have already guessed, right? So we need to generate unique ticket identifiers, right? Or unique ticket IDs basically. Yep. So for that one, we'll be going with a UUID, right? So we can just go with a UUID version 4 as well. Let's go with a UUID. That's enough actually, right? So let's make use of, let's do one thing. I'll just go with from enum actually. We need enum, right? So let's import here enum. We are just importing standard libraries. Yep, in simple terms actually. Next, enum, it is used to define the vehicle type enum, right? Clear, comma, self documenting. So we have discussed this one already, right? So yep, let's move on with the further things. Now from typing, so let me do one thing. I'll just go with import optimal. So next, let me go with the dict, nothing but the dictionary. Next, let me go with a list as well, right? So type hints for the readability. Yep. So this is the type hints for the readability. Next, let's define the vehicle types as an enum, right? So I'll just go with the class. Let me go with vehicle type. Let me go with the vehicle type, right? So I'll just go with the enum. So this is fine. So within this class, each member maps to the numeric size class, right? 1 is equivalent to the small, 2 is equivalent to the medium, 3 is equivalent to the large, right? So I'll just go with this one. What do we call? Motorcycle. Yep. So this is fine. The second one is equivalent to this one. Car equivalent to 2. Then let's go with a bus equals to 2. Yep. So next, what shall we do? So each member here maps to the numeric size class, right? 1 is nothing but small, this one motorcycle. 2 is nothing but this one medium. We have set that one to the car, and 3 is nothing but large, nothing but we have set this one to the bus. Yep. So this is fine, I believe. Next step, let's map each vehicle type to the minimum slot size that it requires, right? So this keeps vehicle to slot logic isolated and easy to change. Yeah, let's make use of it. So I'll just go with here. Mm, Go with vehicle to min. Sorry, vehicle to min slot. Yeah, so this is fine. So this is fine. I'll just go with a vehicle type here. This one vehicle type dot motorcycle. So yep, showing motorcycle. Let me set this one to the 1. Yeah, yep. Sorry. Yep. The next one is this one vehicle type. Just go with vehicle type dot car. So here 2. This is also fine. Let me go with vehicle type here. So this one bus. So this is fine. This is 3. Yep. We are done with this apartment successfully. Yep. So next, let's go with the vehicle object. Nothing but simple data holder for the plate and type, right? So I'll just go with a class vehicle initially, main class. So I'll just go with a class vehicle here. Within the vehicle class, first let's go with the initialization part or the constructor part here. So this one will be def init. So here along with the self, I need plate as well. Plate actually, which is of the type string as discussed in the UML diagram. Let's go with a vehicle type here. Vehicle type, which is of the type vehicle type. So let me give here vehicle type. So this is fine. Yep. First thing here is to store the registration plate string, right? I'll just go with a self.plate. Let me assign this one to the plate. So this is fine. Next thing is let's store the vehicle type enum, nothing but motorcycle or car or bus, right? So I'll just go with self.v type, nothing but the vehicle type here. Let me set this one to the v type, nothing but vehicle type. So this is fine. Next, let's move on with a helper method. This one, what do we call a representation? So this is just the friendly representation used in prints as well as the logs, right? So I'll just go with def representation. So this is fine. Let me remove this one. Uh, Let me return. What shall I return? So let's make use of the string interpolation here. So I'll just go with vehicle here. So this is fine. What shall I pass here? Plate actually, nothing but I'll just go with the self as we're making use of the class self.plate. So this is fine. Along with it, let me go with vehicle type as well. This is not showing. Yeah, vehicle type v type dot name. Right. Yep. So this is fine, man. Yeah. So somewhere I have done something wrong. So I have closed this one. Let me remove this one and let's do one thing. Let me close this one over here. Right, so this is fine. Next, we are done with the vehicle class actually. Next, let's go with a parking slot here. No, nothing but parking slot class, which represents a single parking space, right? So I'll just go with a class. So this one will be parking slot, parking slot. Yeah. First, let's go with the initialization part here. Let me go with init. So this is fine. Init along with the self, I need certain things. So I'll just go with slot ID. Let me go with slot ID here. So this is fine, which is of the type string, which is of the type string. And let me go with size. Let me go with size, which is of the type int as well. Then let me go with level ID. Also, let me go with the level ID, which is of the type int, which is of the type int. Yeah. So this is fine. Yeah. So let's go with a unique identifier for this particular slot. So one simple example is L1 S3, right? So let's go with a unique identifier for this slot. So I'll just go with here slot has to show, not showing. Let me type this one. Slot ID actually. Slot ID. Let's set this one to the slot ID. This has to show. Yep. So this is fine. Next, let's go with the integer slot size. 1 is equivalent to small again, 2 is equivalent to the medium, and 3 is equal to the large, right? I'll just go with here size actually. Size, let me assign this one to the size. So this is fine. Next, let's go with the level number the slot belongs to basically. We have to select the level ID, right? So I'll just go with the level ID here. Level ID, let me set this one to the level ID or initialize this one to the level ID. Finally, we need to know which vehicle occupies this particular slot, right? So we have to set this one to none when the slot is actually free. Yep. So this one we can just write it in this way. Let's make use of the occupied by actually. Yep. So I'll just go with occupied by. So this is optimal, optimal of vehicle. So this is fine equals none, equals none. Yep. So this is fine. Next, let's go with a one more helper method or the function, nothing but is free, right? Is free. So this is fine. Let me go with the self actually. Yep. Let's return true if no vehicle currently occupies this particular slot. So I'll just go with the return here, occupied by. So let me go with occupied by is none. Yeah, is none. Yep. So this is fine. Next, let's go with a fits actually. Yep. So I'll just go with a this one helper method fits. Let me go with the parameter vehicle here, which is of the type vehicle itself. Yep, this is fine. So let's set this one to the boolean. Yep. So this is fine. So within the fits helper method, now let's return true if the slot is free. And also the slot size should be greater than or equal to vehicle's required size, right? So let's do that. So let's write here, return is free. Let me go with, yep, is free and size. We have to check whether it is greater than or equal to, we have used vehicle to min slot, I believe. Yeah, let me call this one over here and let me pass the vehicle type. Yep, so this one vehicle type. So this is fine. Again, now let's go with the representation part again. So we have to show the this one slot ID, size, and the occupant. Right. So these three things we have to show. What are the three things that we need to show? Slot ID, size, and occupant. Right. Or we have to set that one to the free. Right. For the debugging purpose, basically. Yep. For the debugging purpose, we are doing this actually. I'll just go with here presentation. Let me remove this. Along with the self, we don't need anything, I believe here, right? So I'll just go with the occupant, O double C variable, self dot. So let me go with occupied by dot plate if occupied by, yep, uh, else we have to set this one free as discussed. Yep, so this is fine. Now let's return, what we need to return actually, F followed by this one, slot. Actually, this is fine. Slot, this is fine. I'll just go with slot ID. This is also fine. Then let me do one thing. Let me go with the size actually, size, and let me set this one to the dot size. So this is also fine. So let me go with occupant here. So I'll just call here. So this is fine now. Yep. Yeah. Yep. Let me come out of this one entirely. Now, let's go with a level. Level in the sense, let's go with a group of slots on the same floor or level, right? So I'll just go with here new class actually. Name level. Yep. So this is fine. So within the level class first, as usual, let's go with the initialization part or the constructor part. Yep. So I'll just go with the def init. So along with a self, I need certain things, nothing but level ID, which is of the type integer, nothing but int. Also, let me, I also need slots here. So let me give just of the type listing, list actually. So let me pass the parking slot here. So this is fine. Yeah. So within this, I have to initialize certain things. Just give me a second here. So yeah, let's continue here. Let's go with a level identifier, nothing but one based. So I'll just go with self dot here, level ID. So here, yeah, let me go with the level ID and let me initialize this one to the level ID itself. Yep, so this is fine. Again, let me consider slots here and let me initialize this one to the slots itself. So now we are done with the level class actually. Next, let's move on with the this one ticket class. Why we need the ticket class actually? So we have to issue the ticket at the parking time, right? So mainly ticket class consists of the or contains metadata for the parked vehicle. Yeah. So this is fine. Let's move on with the ticket. So I'll just go with a class ticket here. So this is fine. Next, let's go with def here. Again, the same thing, initialization part. So along with the self, I need certain things here. So I'll just go with ticket ID, ticket ID, which is of the type string. So this is fine. Plate, which is of the type string. So this is fine. Let me go with a slot ID. This is also fine, which is of the type string. Again, also let me go with a parked at actually, which is of the type float, which is of the type float. So these are the things that I need actually. So let's initialize certain things. First, I'll just go with ticket ID. Yep. So let me type ticket ID and let me initialize this one to ticket ID. This has to show. Yep. So this is fine. Next, let's go with the associated vehicle plate. Nothing but we have considered plate here, right? So let me assign this one to the or initialize this one to the plate. Next, we need to know which slot the vehicle occupied, right? So for that one, we need slot ID actually. I'll just go with slot ID. This is fine. Let me initialize this one to the slot ID. Yep. So this is fine. The final one is let's go with the timestamp, nothing but seconds since epoch, right? So this is fine. Second since epoch, right? So when parking occurred. So I'll just go with a parked at actually. So this is going to be the correct one, I believe. I'll just go with a parked at actually, and let me initialize this one with the parked at itself. So this is fine. So we are done with this part, man. We are done with this part, initialization part. Next, let's go with this one. I need representation again, actually. So where is this one? Representation. Along with the self, I don't need anything, I believe. So this is helpful when pricing the ticket object. So we have to price, right? We have to set the price for the ticket, actually. So this is helpful when this one. Printing the ticket object, sorry, not pricing actually. So we have to go with the price as well, actually fee. So this is fine. This particular this one helper method representation usually we make use of, right? So this is helpful when printing the ticket object. So let me return something over here. Return. So this one I'll just go with the ticket here. So this is fine. So I'll just go with dot ticket ID. So this is also fine. And let me go with plate equals. So I'll just go with self dot plate and also slot equals. Let me go with dot slot ID. So let me go with the slot ID. This is also fine. Let me go with it here. Let me go with dot. Let me go with a park date here. Yes, this is showing correct. So do we need to go with any other thing actually? This is fine. This is enough, I believe. Yep, we are done with this part, man. Now let's do one thing. We are done with the representation part as well. This is fine, I believe, for the this one. What do we call ticket class? So let's move on with the this one. What do we call parking lot class, right? So main class actually. I'll just go with class parking lot. So this is fine as well. So parking lot, let me go with the initialization part here. First, nothing but this one initialization or the constructor part. So along with the self, I need certain things. One is levels. Uh, this one actually, what do you say? List of level. This is fine. The next part is we have to store the levels in order. So we apply this one first fit algorithm across the levels. We have already discussed the algorithm that we'll be making use of, right? Algorithmic, this one, algorithm choice. So earlier, so we have discussed everything and then we are writing the code actually. Yeah, we will be going with the first fit across the levels algorithm. Yeah. So I'll just go with here self dot levels. Let me set this one to the levels. So this is fine. The next part is I'll just go with self dot ticket map actually. Ticket map. So let me do one thing. Let me go with here dictionary dict of. Let me go with string as well as let me pass this one pass the ticket actually. Ticket we have to consider capital T, right? So this is showing One second. Small t actually. One second. Let me go with the capital T here. This is fine. Ticket is not defined. One second. One second. So we are going with the parking. One second. Just give me a second. Yeah, I have given the class name ticket. This one has to be capital T actually. Sorry. Yep. Now the error is gone. Yep. So this is fine. Let's do one thing. We are done with this part, I believe. Yeah. Let me set this one to the as we had made use of the dictionary. So this is fine. Let's go with a map plate, nothing but ticket ID of this one. Quick lookup by plate, right? So I'll just go with self dot here plate map. So I'll just go with plate map of dictionary. So this is fine. Mm, let me set this one to the dictionary. So this is fine. Empty dict actually. So finally, let's go with a single log to got the modifications, right? So this is coarse grain for the simplicity, right? I'll just go with a self dot log equals threading dot log. So this is also fine. Yep. So the next step, what we'll do. So let's go with a create demo lot, right? Create demo lot. Let's go with a create demo lot. So I'll just mention here this one class method. Yep. So this is fine. Let's move on with the further things here. I'll just go with the def, the helper method, create demo lot here, right? So what are the things that I need here? Class. Also, I need the level count as well. So let's set this one to the level count to 2 initially. So I'll just go with the slots per level. Slots per level. Let me set this one to the 10 actually. Yep. So this is fine as well. Here basically, it's a factory to create a demo lot with a predictable slot mix. Yeah, first two slots are small, nothing but when size is equivalent to the one. Middle slots medium when size is equivalent to the two, and last two slots large when size is equivalent to the three. Right. So this returns a parking lot instance ready for the demo. Right. So this is fine, man. So let's do one thing now. Let's set the levels to the empty array. The second one, next one is for li and range actually in range. So let me go with the level count actually. So this is fine. Level count. Yep. Let me set the slots to the empty array as well. So this is also fine. Let me go with the for loop here. SIN the range in the range. So let me set this one. Let me pass slots per level actually. We have considered in parameter slots per level. Yep. So this is fine. Yep. So first, what we have to decide. So basically, within this for loop, we have to decide the size based on the position for variety, right? So let me do one thing. If si size less than two, actually, then let's set the size to size. It is not showing. Okay, let me type this one. Let me assign the size to one. Else if I just go with elif here, si less than slots per level, right? So I'll just go with the slots per level here minus 2. Then we can just set the size to, we can just set the size to 2. So this is also fine. The next thing is, let me go with the else. Let me go with the else here. Let me set the size. Sorry, yeah. Let me set the size to 3. So this is also fine, I believe. Yep. So next what we will do, so let's go with a slot ID, right? So we have to build the human friendly slot ID here. So I'll just go with a slot ID here and let me assign this one to the, so let me make use of the string interpolation here. So this will be L followed by Li plus 1 li plus 1. So this is fine. Minus. So what we'll be doing here? Let me go with s of again. Let me pass the si plus 1. Yeah. Let me leave space here so that this looks good actually. So this is fine. Yeah. We are done with this part, man. After this part, so let's do one thing. Let's append the new parking slot object. We have to actually, I'll just go with here slots. We have to append this one to the slots itself, right? What we need to append to the slots actually, I'll just call the parking slot here. Sorry, parking lot here, class. So this one has to be parking slot, man, not parking lot actually. Yep. So this is fine. This one actually, parking slot. Yeah, parking slot of. So what we need to call here, let me call slot ID. Along with the slot ID, I need size. Along with the size, I need li plus 1. Li plus 1. Yep. Now let's do one thing. Um, we have to append the level with its slots as well. So let's do one thing. Yeah. Let's go with this one. Levels dot append. We have to append to the levels itself, right? What we need to append actually, I'll just call the level over here. Yep. So we have already written level. So this one will be li plus 1 along with the li plus 1. Let me call the slots as well. Yep. So this is fine. Finally, what we need to return here? What we need to return? We need to return a parking lot composed of the levels. So let me return what I need to return. Class of levels actually. Mm, levels. Yep. So this is it. Yep. So we are done with a creating demo lot. Yep. So we are done with creating demo lot. Now let's do one thing. Let's go with a generate ticket ID. We have to generate the ticket ID, right? Let's do one thing. Let's write that helper method. I'll just go with generate ticket ID. So here, let me pass the self here. So this is fine. Which is of the type string. Yep. So within this helper method, so basically we have to produce a short unique ID using UUID4. So we'll be making use of the UUID4, right? So we have imported UUID, WID, if you remember, right? So we have to, so we will produce a short unique ID using UUID4 and slice it to keep it compact for the demo purpose, right? So let's do one thing. I'll just go with the return here string str of UUID here. So this is fine. Let me give UUID 4 along with it. Yep, let's do one thing. Set this one till 8. Yep, so this is fine. We are just slicing, right? As I've said. So this is fine. Now let's do one thing. Let's go with a helper method. What do we call? Park vehicle. Park underscore vehicle. Yep, so let's go with self. Along with the self, I need vehicle. So this one, which is of that type vehicle. So this is fine. Let me leave space here. Yep. Let me leave the space here. Yep. So again, so let me go with, this is not optimal, man. Optional actually. Go with the optional of, let me go with a ticket. Yep. So this is fine. Why this is showing here? Optional is not defined actually. We haven't defined optional environment. So this is 1 second. 1 second. We haven't used optional environment. So this is just indicate we are going with this one. Park vehicle I have given, so this is fine. We are making use of this one self, comma vehicle, JCLA vehicle, which is of the type vehicle as well. So this is fine. Optional, optional of ticket, right? So this is fine actually. Yep. So why this is showing error? It's not defined. We don't have to. Anyway, let's move on with the further things here. So here, let's do one thing. We have to park a vehicle using first fit algorithm. We know this one. So first, let's do one thing. Let's acquire the lock for thread safe mutation. Then, if the plate is already parked, right? If the plate is already parked, then we can just return the existing ticket. Yep, that we can do. Then followed by this, we can iterate the levels, then slots, right? On first fit, occupy the first slot, occupy the slot actually, and then issue the ticket. Yep. Finally, we can just return the ticket or none if no suitable slot is found. Yep. So let's do that. So this is fine. I'll just go with here with lock actually. Yep. So this is fine. Next step, let's go with a quick check here. Suppose if this plate is already parked or not. Let's check that one. So I'll just go with vehicle here dot plate in plate map, right? So I'll just go with a plate map. So this is fine. The next one would be we have to return the existing ticket, nothing but item potent park attempt, right? So I'll just go with the TID here. So this one equals self dot plate map. So this is fine. I'll just go with a vehicle dot plate. I'll just go with vehicle dot plate. Yep. So this is fine, man. I'll just go with a return here. I'll just go with the ticket map. Self dot ticket map. Fine. We go with get of TID. Yep, so this is fine. The next step would be we have to iterate over levels and slots to find the first fitting free slot. Yeah, so I'll just go with for level and levels actually in levels. So this is fine. Let me go with for slot and level dot. I'll just go with the slots. Let's go with the slots here. Let me go with simple if condition. If slot dot fits of, let me go with the vehicle. Yep, let me go with the vehicle. Fits vehicle. So then we have to mark the slot as occupied with occupied with by this particular vehicle, right? So I'll just go with slot dot occupied by. So this has to show, yep, occupied by. Let me assign this one to the vehicle. Yep, so this is fine. Next, we have to generate and record the ticket. So for that, I'll just go with the ticket ID here. So let me type this ticket ID and I'll just go with the self dot. So let me go with generate ticket here. Yep, generate ticket ID. Mm, yep, so this is also fine. Let me assign T2. We have already written the class ticket actually, ticket class actually. I'll just go with the ticket ID. Let me pass the ticket ID along with the ticket ID. Let me go with the vehicle dot plate. So this has to show. Yep, so this is fine. Slot dot, let me go with slot ID here. This has to show. Yep, we are correct. We're at the correct route actually. So I'll just go with time dot time here. Yep, this, yeah, this one also should show. Let me pass the, or let me write the, let me give the parenthesis here. So this is fine, man. Now we have to store the ticket and index by the plate, right? So I'll just go with here ticket. Where is the ticket actually? Yeah, this ticket map of, let me pass the ticket ID within the array. This is fine. Let me assign this one to the T. Yep. The next part is, let me go with plate map. Let me go with a plate map. So this is also fine. Of, let me go with here vehicle dot plate, right? So I'll just go with vehicle dot plate. Yep. So let me assign this one to the ticket ID. Let me assign this one to the ticket ID. Yep. Finally, we have to return none. If the loop completes, no slot was found. Then in that case, we have to return none. Yeah, we have to return none. So this is fine, man. Yeah, now we are done with this helper method, park vehicle actually. We are done with this. So next, let's do one thing. Let's go with the helper method leave actually, or the function leave, right? So I'll just go with def here, leave leave. So along with the self, I need one more thing that is nothing but ticket ID. Ticket ID, which is of the type string actually. Yep. Again, so this is optional. So let me give here optional. So this will give the error. Just ignore this one for now. So I'll just go with a dict here, right? So this is fine, man. So within the helper method leave, what we will be doing. So let me explain you this one. Just listen to this carefully. So we will unpark a vehicle given a ticket ID, right? So we will unpark a vehicle given a ticket ID. So within this one, first we have to acquire the lock. Yeah, we have to acquire the lock at any cost, right? So this is fine. We have to validate that whether ticket exists or not. So we have to validate at any cost whether ticket exists or not, right? So that one also we have to do. So we have to free the occupied slot. So once we are unparking the vehicle, that slot has to be freed, right? So we have to free the occupied slot. So this is one thing. The fourth one is we have to compute or calculate the parking duration as well, along with the fee and fee, nothing but simple hardly this one rounding up. So this is fine. Final one is we have to clean up maps and return the details or none if the ticket is invalid, right? So I'll just go with here. Again, let me go with a lock. Yep, this has to show within this. First, let's go with a lookup ticket actually. Let me assign T2 here. Let me go with the ticket map here. Dot get of, let me pass the ticket ID, right? So I'll just pass the ticket ID. Yep. If not T, then within the if condition, if not T, then it's an invalid ticket, right? So let me return none actually. Let me return none actually. Next, what shall we do? We have to find the slot object and we have to mark it free, right? So let's move on with a for loop actually. For level and self dot this one levels actually. Uh, levels. So this is fine. So within this for loop, again, let me go with one more for loop actually. We have to consider individual slot, right? Right. So this one for slot in level dot slots actually. This has to show. Yep. So within the for loop, what we have to do, let me write the simple if condition. If the slot ID value is equivalent to the this one slot dot slot ID, that value is equivalent to the t dot slot ID, then we have to set the occupied by none actually, and then we have to break from there, right? So I'll just go with if condition slot dot slot ID. If it is equivalent to t dot slot ID, this has to show here slot ID. So then what we have to do, I'll just go with slot dot occupied by. So let me go with occupied by here. Let me set this one to the none. Let me set this one to the none. Also, we have to break from here. So I'll just make use of the break statement. So this is fine, I believe. Yep. So next step, let's move on with the further things. We have to compute or calculate the duration in seconds. So let me go with the park seconds variable name here. And let me assign this one to the time dot time. This is fine. Minus t dot park data. So let me select this one. This is fine. Next, let's round up to the next star, meaning we have to add or we will be adding 3599 seconds, right? So 3599 seconds, then integer divide by 3600, nothing but 3600. So I'll just go with hours here equals int. So this will be, let me select here, not showing here. Yeah, park seconds plus 3599 as discussed divided by 3600. Yep, so this is also fine. Now we are done with the calculation part. Now let's do one thing. Let's go with a very simple pricings, right? So let's go with 10 units per hour, right? So minimum 10, right? I'll just go with fee. Let me assign this one to the hours into 10 if parse greater than 0, else 10. Yep, else 10. Right. So after the calculation, we have to remove the records, right? So yeah, after unpacking, we have to remove the records, right? So I'll just do one thing. Let me go with delete dot ticket map actually. I'll pass the ticket ID. Based on the ticket ID itself, we will delete, right? So I'll just go with the if condition here, simple if condition. If t dot plate in self dot this one plate map. This has to show. Yep. So this is fine. So then within the if condition, let me do one thing. I'll just go with delete self dot plate here. Yeah, self dot plate map here. Sorry, of t dot plate. Yep. So this is fine, man. Yep. Then we are at the end of this particular helper method. So we have to return the structured result for caller to print or process. So let me return here. So what shall I return? So let's do one thing. Within the strings, I'll just give here ticket and let me pass the T. This is fine. This has to show, not showing. Uh, yep, still fine. Oh, we have to close this one here itself. So that is the reason it is not showing actually. This is fine. If I pass T now, yep, this is showing. Yep. Now let me go with fee. Yep. So this one, let me pass the fee here. Yeah, this is also fine. Then let's go with one more thing, duration seconds as well. So I'll just go with duration seconds. So this is fine as well. What should I pass actually? Int of this one, parked seconds actually. Let me go with parked seconds, right? So this is fine. Yep. Let's do one thing. Next, let's move on with a helper method status, right? So just give me a second here. So I'll just go with status here of let me pass self. I'll just go with a the dictionary. So yeah, what we'll be doing within this method, we will be producing a snapshot of total or free or occupied slots, right? Total or free or occupied slots, right? So basically we'll be returning or it returns dict with the total slots, right? Free slots occupied as well as the per level map. Let's write this one very quickly, man. Yeah. So I'll just go with lock actually. Yep. So within this, let me initialize total to 0. Also, let me initialize free to 0. Also, let's do one thing. Let me go with per level here. Let me go with per level. So this is also fine. Then let's iterate each level to count the free slots actually. Let's move on with the for loop, man. So I'll just go with for level and levels and levels. So this is fine. Let me go with this one level total actually. Let me go with level total and let me go with length of this one level dot slots. So this is also fine, man. Yeah. So now let's do one thing. Let's go with the generator expression that counts free slots on the level. Let me go with level free here. Level. Let me make use of the level free variable name here. So this would be sum of what are the things? One for SN. So I'll just go with level dot slots. This has to show. Yep, level dot slots. If this one, let's make use of the is from here. So is free, right? Sorry, did I say is from? Sorry, is free actually. Yep. So next, let's go with a. As per the discussion, we have to go with a per level itself, right? So this will be level dot level ID. So let me go with the level ID as well. Here, let me do one thing. Let me go with the total here. So let me go with the total. So here, so this one will be level total and also let's go with free. So free, what we need to pass here, level free, right? So I'll just pass level free here. Not showing this one more. Yep, this is fine. Next part we have to go with total equals total plus level total. Level total, this one. Yep. The next part is free equals free plus level free actually. Yep. So this is also fine. Next, let me go with the actually occupied actually, right? So I'll just go with occupied. Let me go with occupied equals total minus free. Total minus free. So this is also fine. The final one is we have to return certain things. So I'll just go with the return. So this one will be total slots. Total slots. So this is fine. Let me pass the total. Yep. So let me go with free slots. Free slots. So this is also fine. Let me pass free. Yep. Also, let me go with occupied. Mm, Let me pass occupied here. This is also fine. Yep. The next part is let's go with the per level as well. Yep. So within the strings, let me go with per level. So here in this case, I'll just go with per level, right? So these are the things. These are enough, I believe. Yeah. Per level. Yep. One second. Now let's continue with the other helper methods one. Yeah, we are done with this part actually. Now let's go with the this one, find by plate actually. Yep. So we can just go with some more helper methods named find by plate helper method. Also, let's go with the dump slots, right? So these two things we are left with actually. Let's go with find by plates as well as the dump slots actually. So I'll explain why we'll be making use of this. First, let's go with a find by plate actually. I'll just go with find by plate here. So this is fine. Let me go with self comma plate, which is of the type string. So this is fine. So again, let me mark this one as optional. Let me pass ticket. Yep. So this is fine. So why we'll be making use of, or why we are making use of the find by plate helper method here. So we have to look up an active this one ticket by vehicle plate, right? So for that purpose, also basically what it returns the ticket or none if not found. Yeah, so this will be a simple one, man. So I'll just go with here lock again. So within this, let me set the ticket ID, nothing but TID to the self dot here plate map. Yep, plate map. So let me make use of the get operation here. Get operation here. Let me pass the plate here. So this is one second. So let's continue with the same actually. So yeah, sorry for that. Let's continue here. So I'll just we have just passed the plate, right? So if of ticket ID, nothing but TID here. Yes. If of TID, then what we need to return here? Let me return this one ticket underscore map. So let's make use of the get to get the value of this one ticket ID value, right? So TID value basically ticket ID. Finally, let's return, else let's return none as per the discussion. Yep, so this is fine. Now we are left with only one helper method, nothing but dump slots, right? So I'll explain why we'll be making use of this one. We have to dump the slots, man. By looking at the name itself, after unpacking actually, we have to dump the slots, right? So yeah, that we'll be doing basically. Let me explain that one in detail. Just give me a second here. I'll just write here. This is of the type string actually. Let me mention str. So within this helper method dump slots, so we will be going with a human readable dump of every slot for demo or debugging. Yeah. So we'll show the level, slot ID, as well as size and occupant, right? Or we will be setting that one to free. Yep. So let's do this one. So this is also simple. Let me go with lock actually. Yep, let me go with the lock here. The next one, let's go with lines. Yep, so let me assign this one. This is fine. Let me initialize this one to the this one empty array. This is fine. Let's move on with the for loop, man. Very simple for loop. So this one for level and self dot levels. Let me pass the levels. So this is also fine. Let me pass or let me append what we need to append to the lines here actually. So we have to append this one level ID, right? So let's make use of the string interpolation here. So I'll just go with level. So this is fine. This will be will dot. Let me pass the level ID. So this has to show, man, not showing. Okay, let me type this one level ID. So this is fine. Oh yeah, why this is not showing? Because we are this one writing this one within the parenthesis actually. We have to write this one within the flower braces actually. Now this has to show, yeah, level ID. We are making use of the string interpolation. We have to make use of this one, right? Flower braces. So this is fine, flower bracket actually. Yep, so this is fine. Now let's write the simple for loop here. So for sn level dot slots. So this is fine. So let me go with O double C, nothing but the occupied or the occupant actually. Yes dot. So let me go with occupied by, sorry, what did I press? Man. Let me go with the occupied by dot plate, mm, dot plate actually. If s dot occupied by, so this is also fine. Else we have to set free. Else we have to set free. Yep. So this is fine. Next, let's do one thing. So what we need to append here, lines dot append. So I'll just go with f, nothing but, so we'll be going with a string interpolation. I'll just go with s dot. So let me go with 1 second. Mm, 1 second. I'll just go with not showing. Okay. S dot. So this is showing parking lot. Okay. Anyways, I'll just go with a slot ID here. This is fine. Uh, Let me go with size equals. Hmm. First, we are just printing the slot ID actually. This is fine. Let me go with s dot size. Again, this is not showing size. Oh, I have not mentioned the this one at all. Again, this is not showing. Let me type this one entirely. Finally, let me pass the occupant. So this one, O double C. Yep. So this is fine. We are done with this part actually. Why this is showing like this? Uh, was not closed. F is not defined. Okay, else we are just going with the if instead of occupied by, else we are going with the free. This is fine. Lines dot append. Yep, we are keeping this one correct actually. F we have left. Oh, mm, yep. So now the error is gone, I believe. Yep. So this was the actually this was the mistake actually. We have to go with the double inverted comma after F, right, for the string interpolation. So we have passed slot ID. That is the reason it was not showing, I believe. Now it has to show. Yep, actually that was the reason. So this is fine, man. Occupied this one, the size, this has to show actually. This is fine. We have corrected it. Now we are left with only one thing, nothing but we have to join all the lines into the single multi-line string, right? So let me return here. What shall we return? I'll just go with a slash n here. So this is fine. Dot join. This is also fine. Let me pass the lines. Let me pass the lines. Yep. So this is also fine. Yeah, we are done with this part, man. Let's go with a demo scenario, meaning we have to create lot, we have to park the vehicles, and we have to park this one, unpark one, and we have to print the status. So let me do one thing. Let me get the this one, what do we call, demo usage from the or the demo scenario from the Google actually. Just give me a second here. Yeah, let me paste it over here. Yes, so this is the demo scenario we'll be going with actually. Yep, so this is fine. Where did it go actually? Yeah, we'll be starting from here. So this will be the demo scenario from here, line number 156 to from line number this one 199. So what we are doing here basically, so we are calling the parking lot here. This is fine for parking the vehicle. See, this is actually vehicle type we are mentioning car, motorcycle as well as the bus. So this is for the parking vehicles actually. This is fine. Now we are just going with the tickets for being in cars. So this is fine. Plate name, these things we are mentioning. So this is fine, man. We are just going with a print statement for the interactive purpose. This is also fine. So we are just leaving one car, meaning we are simulating some time here, right? We are simulating some time here. Small pause just to create the non-zero duration here. We are going with a sleep, right? So as we are going with the threading, actually, we are making use of the threading, right? So we are going with a multi-threading here. So this is fine. If tickets, then this is fine. Vehicle ticket we are passing. So this is fine. Final status. Yeah. So the output that we need to get here based on the demo scenario that we have considered actually. So what's the output that we need to get? Basically, total slots we are going with, free slots we are going with, occupied we are going with, per level we are going with. We have made use of the print statement for that, right? So that we have to get in first line. Then we are displaying this one, parked vehicles actually with the vehicle plates actually. See here, KA this 101. So I have just considered this one actually, random numbers, right? So this one as a car we are going, this one as a car as well. So this is motorcycle, this one is bus. So this one we are printing. So if we will be generating the ticket along with the random numbers, right? So ticket ID for the slot as well. So we are going with a L1, S3, L1, S4 like that. We are just going with the slots S1, S2, S3, S4 along with the levels, right? L1 meaning level actually, level 1, level 2 like that. Yep. So status after parking, we have to get the status after parking accordingly with the what code we have written. Total slots, we are printing total slots, free slots, occupied slots, this one per level as well as other stuff, right? So this is fine. Finally, what we are doing, we are just going with a slot dump, right? So within the level 1, we have to get all the things actually. So whatever the things, this one basically it's completely based on the slot dump actually, right? So level 1 and level 2 we are printing. So this is fine. And vehicle along with the number, this one whatever the vehicle has left actually. So unparked, right? So unparking stage, certain particular vehicle, we are simulating something over here. Just give me a second here. Yeah. Leave one car actually. One car is leaving. We are displaying the vehicle number as well. Similarly to the this one. This one itself actually we are going with actually. This one vehicle, this one with the vehicle number left actually. Fee, we are displaying the fee actually along with the duration actually. Duration is nothing but the hours. In hours we are going, right? So for 1 hour, we are displaying the 10 units. If you remember, while explaining the code or while writing the code itself, we have discussed this one. Next, we are going with the final slots. Within the final slots, we are going with the total slots, free slots, occupied, per level, and other stuff, right? Per level and other stuff, right? So finally, we will get the final slot dump actually. Level 1, level 2. In our case, we have considered only level 1 and level 2, right? So this is fine, I believe. So this is the output that we need to get. Yeah. So we have successfully written the code. Let me do one thing. Let me do one thing. I'll just go with here. Let me rename. Sorry. Let me copy the entire file name here. Let me enlarge this one. Let me give Python followed by the file name.py. Let me hit the enter. We have the error somewhere. Import optimal, cannot import name optimal from typing. So where is this actually? Did you mean optional? Yeah, I meant optional actually. We are not making use of optimal anywhere. Where is this? The line number 9. Okay, at starting itself 9. So this is not optimal. So oh, that is the reason it was showing actually error. So this has to be optional actually. Optional, yeah. So now the error has to be gone actually. So this one optional actually. Yep. Now most of this thing. So see here, this error is gone. This error is gone. Yeah. So that is the reason. While importing, I have given optimal. That was the reason it was showing this one optimal in the suggestions rather than the optional. So this is fine, man. Now we have to get the correct output. Let's see. Let's check the same actually. Let's see whether we have some error actually. Yep. Yeah. See, as per this one, total initially parking lot, we have successfully created the parking lot. Let me enlarge this one accordingly with what code we have written. So total slots we have 16, free slots initially we have 16, occupied 0 initially, per level we are displaying this one total 8, this one free 8, this one level 1 we have total 8 free 8, and level 2 we have total 8 free 8. Simple one, very simple one. First, initially no space for this one, initially no space for this one motorcycle as well as the this one. These are the cars and motorcycles we are going with. Yep. So status after parking, total slot 16, free slots 12 actually, free slots 12, occupied 4 actually. These 4 we have parked actually, right? So these 4 we have parked, right? So total 8, free 5 in the level 1, total 8, so free 7 in the this one, what do we call, a level 2 actually. For level 1 we have considered 3 slots. For level 2 we have considered only 1 slot. So here slot dump you can check, right? S1 size, so this one we have allocated to the this one first vehicle, this one double 3, so this one third vehicle here, double one and double two, this one double one double two, these two things we have allocated to here actually, size 3, S7 as well as the S8. So one we are left with actually double one is fine, double two double three double four, this one, this car we have allocated to the level 2 actually, level 2 S7 actually, this is fine. Yep, this is the slot dump. We are good with it. Next, let's move on with the final status. Final status, we have total slot 16, free slots 12, occupied 4 per level. The same thing actually, 5 and free we have 7. This is fine. Level 1 and level 2. Final slot dump. So this one, level 1, this is fine. Level 2, this is also fine. Yeah. So we are going with this one actually. One vehicle has left, right? So after one vehicle has left, actually, we have to get the occupied here free slots 12, free slots 13 actually. That vehicle left, it is not showing. We have written in the demo this one. See here, final status. This is fine. This and all fine. Where did it go actually? Somewhere we are simulating, right? So this is fine. 1 second, just give me a second here. So this we have demo scenario, within the demo scenario somewhere. Yeah. See here, leave one car. We are leaving this car actually. Mainly this one actually. We are unpacking this one, right? So after that one, we have to get the this one. What do we call? Uh, Free this one. We have to get 13 instead of the 12 actually, right? So that one we are not getting. Let's check what is wrong here. So let's check what is wrong here actually. In the parking slot actually. Or so let me come to the park vehicle here. I'll just give me a second here. Yeah. So within the 1 second. Yep. So within the park vehicle method, helper method, so we are just returning none actually, right? So instead of returning none, we have to return T, I believe. So we have to return the actual ticket object T, right? So instead I have written none. So let's do one thing. Let me change this one to the T actually. So this is fine. And also there is this one, what do we call, typo in the enum values actually, right? So I'll just go with here. So this one, this is fine. Let's set this one to the 3 rather than the 2. Yep. So let me close this one. Instead of 2, let me set this one to the 3. Yeah. So this is fine. uh this is fine. So previously the line number 103 we changed something, right? So return T, else we have to return none actually. Yep, return T actually, else we have to return none. So I haven't written this one at all. So let me return none here. Right, so this is fine, man. Yeah, now this has to work correctly. Let's check. I'll just give your control J. First, how if it is working correctly. Start dump. Yeah, now we are getting correct one. Yep, see here, vehicle K01, this one, K01 double A double one left actually. Fee duration, we have kept that one to the 10 units per 1 hour, right? So fee, this one 10, duration is nothing but 1 hour here. Final status, we are getting total slot 16. Now free slot says 13. So we had 12 free slots actually. So this vehicle got unpacked actually. We are unpacking this vehicle. Actually, this vehicle left actually, right? And we have set the fee to 10 as it was parked for 1 hour. Now the free slots are 13 instead of the 12. This got updated, right? So we have written absolutely correct this one correct code. Now only level 1, only within the level 1 there are 3 vehicles. One is 3333, 2222, ending at 4444, right? 1111 has left from the level 2, right? Level 2 slot S7, actually level 2 slot S7. We have size 3 here. See, now we have size 3 here, right? So now we are getting the absolute correct output, right? So this is simple, but yet we have written this one somewhat lengthier code. Yep. So this is simple, man. Yep. We are done with the coding part, right? So we are done with the coding part. I hope this part is completely clear. Whatever the code that we have written is completely clear, right? So next, what we're gonna do, so let's do one thing. Let's discuss the limitations of the code and let's discuss the alternative algorithm as well, right? So we have made use of the first and fit algorithm here, right? So instead of that, let's discuss the alternative algorithms and trade-offs as well. Trade-offs in the sense summary. First, let's discuss the limitations of the code, limitations for the code that we have written. Yeah, just give me a second here. Now, yep. First thing, limitations of the current code. Yeah. So first here, single in memory node. When I say single in memory node, so there is no persistence at all here, right? So it restarts and loses all the data. It restarts and it loses all the data, right? So one is the second one is this one, simple fee model. Now, when I say simple, this is not free model. Actually, this is fee. Actually, let me write it over here. Simple fee model, right? Simple fee model in the sense we are just going with a flat per hour rounding, right? So production needs rates, discounts, as well as the receipts if you're going with a production ready code. Yep. So this is fine. Next, uh, the third one is allocation policy naive. Allocation policy naive in the sense first fit algorithm can fragment space, right? So, but no reservation or priority is mentioned here, or we haven't considered any reservation or the priority here, right? Right. So this is fine. Next, let's go with a course lock. When I say course lock, so this is nothing but entire parking lot locked for this one, park or leave. We may limit throughput at scale, right? So this is one thing. Next, let's move on with a no ticket expiry or lost ticket handling or admin operations, right? So this one we have to go with a force remove. Yep. Next, we are not considering any API, meaning we are not considering any REST API or the network interface here. So this is just for the CLI or demo only, as we are just solving the LLD problems, right? So we are just went with a CLI or command line interface or the this one demo only code actually, right? So this is also fine. The final one is no monitoring or persistence for the analysis. No monitoring or persistence for analysis. Yep. So this is fine. So these are some of the limitations for the code that we have written. Next, let's go with let's discuss some alternative algorithms that we can make use of and also the trade-offs, right? Nothing but the summary part. So we can just go with a best fit here. Best fit in the sense we can just by making use of the best fit algo, we can just reduce the fragmentation by choosing the smallest fitting slot. Yeah. Trade-off, nothing but the summary part here is slightly higher compute per allocation or slightly higher calculation per allocation, right? So this is fine. This is also fine. Yeah. For me, I have found the this one. What do we call? First fit actually one of the best algorithms. Yeah. First fit is one of the best algorithms I have found. So that's why I went with it. If you find other algorithms are better or with a better design actually, yeah, with a better design actually, you can just go for it as well. Yep. Right. So I'll just go with, so next thing is we can just go with a greedy by size, this one class pools algorithm as well. So this maintains separate free lists per size, right? So this will be a big of one allocation, right? So this is one of the pros or advantages. So here, um, this needs careful balancing to avoid the starvation when we consider greedy by size class pools. Next, let's go with the reservation plus eviction. Reservation plus eviction is nothing but we can just allow the reservations for some slots with the time windows here. So, but it will be complex, this one. So it will be complex to handle basically, right? So it will be complex to handle the conflicts in other terms. Next, let's go with a distributed design. When I say distributed design, I'm speaking of this one, partition by level or zone with per partition logs, or we can just make use of the central database or the central DB for the global state, actually. Simple summary here would be more complexity as well as the resilience. More complexity as well as the resilience. Next, let's move on with the use of persistent store. Use of persistent store in the sense we can just go with the SQLite or the Redis or the Postgre, right? Or the Postgres actually for crash recovery and multi-process access and multi-process access. The simple trade-off for the summary is here. This will give us the operational overhead. This will give us the operational overhead. Final one is we can just move on with this one. We can just go with the asynchronous processing as well. We can just make use of the queues for the payments or the receipts to improve the response latency. Just to improve the response latency. These are some of the alternatives that I wanted to discuss along with the trade-offs of the summary. So this is going to be the future discussions. Future things that we have to keep in mind. I can just put it in this way. Yeah. So we are done with this one. Designing a parking lot actually. We have successfully designed a parking lot actually. You can just check. Yeah. We have discussed out initially we collected the functional as well as the non-functional requirements. Then we went with this one algorithm choice actually algo choice. Then we went with what do we call that one data model as well as the concurrency. Yes, that one that is very important as well. Then fourth one we went with this one UML diagram actually. Yeah, that's very important. After writing the UML diagram or after preparing the UML diagram, accordingly with the UML diagram we wrote the code actually. Yeah, so we discussed whatever we while writing the code we discussed whatever we were writing, right? So that we did, and we discussed about the output that we got. Initially we got the wrong output, so after one vehicle left we were not getting that one, right? So we did mistake in the this one uh, somewhere within some method. Yeah, we corrected that one. Basically after that we got the correct output. Basically after some vehicle got unpacked actually, we have to free that slot number also gets changed, right? So free slots, this one number actually changes, and within the actually level 2 actually that a vehicle has to be freed from that particular slot as well from the level 2 actually. So that one was not working. So basically after correcting the code, that one worked actually, right? So that one we did. We discussed the output part as well. After this one, discussing the code as well as the output part. So we discussed the limitations for the code that we have written. Finally, we discussed alternative algorithms and the trade-offs, nothing but the summary part. Yep. So we are done with designing the this one parking lot. So we have successfully designed the parking lot, right? So next, let's do one thing. Let's design the vending machine, right? So let's go with yeah, let's design the or let's move on with this one, designing a vending machine. For now, this is it. Thanks for watching, guys.